Everyone. My name is Will Tolbert. Thank you, Professor Yang, for giving us all this opportunity. Very excited to be discussing my robot with you all today. I'm going to be discussing with you the Unitary Go 2 W four-wheeled robot dog, and it belongs to the family of the biomorphic robots. So awesome! Looking forward to getting into it. Let's go. Only got 6 minutes. Got to make good use of the time. So biomorphic robots were designed to mimic biological organisms, right? So humanoids also fit into that family technically, but quadruped robots tend to lean towards the physiology of four-legged mammals, i.e., dogs, cats, things of that nature. A predecessor to the Go2W was the very popular Boston Dynamic Spot. Some of you may have seen the videos of like the dancing robots, the ones that do martial arts and all of that. That's the Boston Dynamics. They make really cool videos. And the Go2 was actually pretty much developed after that, and a lot of people say like it mimics that, but they are very similar in their design. So let's hop into that and tell you a little bit more about the Go 2. So, where can these types of quadruped robots and the Go 2W be found? Pretty much anywhere. Households can utilize them because they're the ultimate pet, right? You don't have to clean up after them, but they can play fetch with you. They can run around with your kids. You don't have to take them for shots or feed them. You just got to plug them in, right? They can be found in manufacturing operations, in industry, security, militaries, and police departments use them for like dangerous ordnance disposal, thing of that nature, surveillance, science, research, and development can be utilized to deploy these robots in very harsh environments where humans may not be so comfortable. So there's a lot of use cases there. Now, what are the problems with these go-to robots specifically? Well, a lot of times these base models are going for very inexpensive prices, right? 1800 is the base, and this thing was just released last year, August 2024. Now they're going for 1800 off the Unitary site. If you buy them retail, they're going to be a lot more expensive, but nowhere near as expensive as their competition, the Boston Dynamic Spot, which is going for around 50,000 when it was first released at base. The problem is when these Go2W robots are released at base, you're literally getting the base level functionality. In order to do any of the cool tricks like scaling walls, breakdancing, things of that nature, you're going to have to do some programming, hop into the toolage yourself. The cool thing is there's tons of open source software and the tools and libraries, GitHub repos out there that give you access to be able to do that, but you do have to have the technical acumen to understand exactly how that works. Or you gotta have a couple extra grand, like around 10 grand, to go about buying the tools and buying the upgrades yourself. One of the two. That's pretty much the biggest gripe. So let's take a history lesson. Let's go back in time. The Go2W robot pretty much started way back in 1940, right? Sparko was the first robotic dog released by Westinghouse in 1940. It was developed, but ultimately it was never actually released for commercial sales. Why? Who knows? The Aibo was Sony's first robotic dog, and it was released in 1999. So this was the first like official robotic dog that was released on a large commercial scale by Sony. Techno followed up with the robotic puppy in 2000. Sega came out with one in 2000 as well, the Poochie. Then there was the iDog, which was released and shipped worldwide in 2005. Now, the founder of the company Unitree is Wang Xingqing. This guy apparently is a genius, right? During his postgraduate studies in Shanghai University, he first came out with the X Dog. So it was actually part of his master's thesis in 2016, the X Dog. And now obviously the predecessors are the Go 1 and Go 2. Go 2W is the latest release, which is the subject of my presentation. It was released last year, August 2024, the wheeled quadruped dog. Now, the kinematics of this thing are awesome, right? Again, this is a four-legged robot, right? It has a rigid body for its joints, its legs, connected by ball joints, right? This allows for awesome relative movement. It's programmed along the X, Y, and Z planes with a free 360-degree rotational movement axis on the Z, right? Now, this allows for forward kinematics for forward movement, inverse kinematics for reverse movement, awesome data interpolation for very fast and intelligent movement and reaction to its external environment. So this is a pretty cool thing. This is a pretty cool robot dog. Mobility. Now, this thing was designed to operate in very difficult terrains, right? It can climb up and down stairs, it can jump and scale walls. It's built for balance on slippery and uneven surfaces. It was designed for shock absorption with the legs, adaptability to be able to switch from walking to rolling automatically without having any types of like external manipulation. It just reacts to its environment. It has multi-terrain awareness, which was pretty much built into the design with high definition cameras, stability from its 3-axis stabilization and thermal image sensory. So it was designed to do a lot. Now, right here, I have provided a bunch of resources. I'm going to send out the whole presentation to our channel via email so that you guys can take a look at some of these awesome resources within the Christoph Yamahata's link here. You'll be able to get access to the JavaScript, Java, and Python Git repos to actually program these robot dogs. Pretty cool. You can check out the Unitree go-to product site here where you can actually acquire the dog if you're looking to do so, or just get some really cool information from the Reddit link. Also, I included below the trigonometry resource guide, which I think is very useful. I'll definitely be using it as a auxiliary or complementary resource for this class, and I think you guys should well. Other than that, thank you very much for taking the time. I really appreciate your patience in going through this. I hope I didn't talk too fast, but I appreciate your patience, and I hope you got some useful information. You guys have a great week. Thank you and take care. Once again, Professor, thank you for this opportunity.